Hi, this is problem number 7 on coplanar non-concurrent system of forces. Uh, this is actually a dam structure which is subjected to a number of forces. Here the question is to determine the point of intersection of the resultant with respect to the base of the dam. Okay, we have to find, means we have to locate the point of intersection of the resultant force with respect to the base. We have to locate this point. We have to locate this point means either we have to find distance from point C or we have to find distance from point O. How to find that distance? X-intercept, using the X-intercept formula. Okay, sigma m by sigma fi formula. You can locate the point of intersection of the resultant with respect to the base of the dam. Okay, so initially we will find sigma fx and sigma fi, means we will find the magnitude of the resultant force. So before that, for 30 kilonewton force, let me calculate the horizontal angle. Just draw a horizontal dotted line here at this point. Okay, so here whatever the angle 60 we have, same angle will be there here, 60 or 60, but the 30 kilonewton force is making an angle of 30 degree with the inclined plane of the dam. Okay, at an angle of 90 degree with the inclined plane of the dam, means 30 kilonewton is perpendicular to the inclined plane of the dam. So the remaining angle, okay, the remaining angle here is how much? 90 minus 60, means you will get 30 degree. Okay, therefore horizontal component will be 30 cos 30, vertical component will be 30 sin 30. Okay, so whatever the angle we have here, the same angle will be here, that is 60 degree, but total angle of 30 kilonewton with this plane, inclined plane, is 90. 90 minus 60 will be 30 degree as horizontal inclination of 30 kilonewton force. Using that 30 degree, we have written the components. Now we will find sigma fx. Sigma fx is equal to sum of forces in x direction. Here we have 50 kilonewton force acting in right direction plus 50, and 30 cos 30 is acting in left direction minus 30 cos 30. Okay, only two horizontal forces are there. The answer is 24 kilonewton. Okay, then sigma fi, sum of forces in y direction. So we have 120 kilonewton force acting in downward direction minus 120, and 30 sin 30 acting in downward direction minus 30 sin 30. Answer is minus 135 kilonewton. Now you can find the resultant force. You know the formula, R is equal to root of sigma fx square plus sigma fi square, which is equal to root of 24 square plus 135 square. I am not taking negative sign because when you make it square, minus into minus it becomes plus. The resultant force that you get is 137.11 kilonewton. Okay, now theta, angle of the resultant force formula, that is tan inverse of sigma fi by sigma fx, which is equal to tan inverse of sigma fi is minus 135 divided by 24. If you calculate the answer, you will get it as 79.91 degree. 79.91 degree. Okay, now we have to locate the point of intersection of the resultant with respect to the base. For that, we have to find position with respect to the point C or with respect to the point O. Okay, now here it is better to take moment about C rather than taking moment about O. Okay, if you take moment about O, no, you will face difficulty in finding the perpendicular distance of this 30 kilonewton force. Okay, Therefore my suggestion is to take moment about C and find x-intercept with respect to the point C. Okay, therefore moment about C, sigma mc is equal to moment of 50 kilonewton force about point C. 50 into, you just draw the line of action for 50 kilonewton force. So this is the line of action, correct? This is the line of action of 50 kilonewton force. So distance of point C from the line of action, how much it is? 2 meter into 2 meter into 2. And about point C, if you apply a rightward force at this edge of the dam, the force will tending to cause clockwise rotation to the dam. So into 2 with the positive sign, so clockwise moment. Then you find moment of 120 kilonewton force. 120 into perpendicular distance, you draw the line of action. So 120 kilonewton, this is the line of action. We have the point C here. Distance of point C from the line of action is how much? See, total is 6. 6 minus this 2 will give as 4 meter. 4 meter. So into 4. Into 4. And about point C, if you apply downward force 120 kilonewton at this point, that force is tending to cause anti-clockwise rotation. Sign is minus about point C. Okay. Then coming to this 30 kilonewton force, no. See here, you can, instead of taking components to find the moments, you can directly take that 30 kilonewton force. Why? I will tell you. See, the perpendicular distance of the point C from the line of action is directly known. Okay, perpendicular distance of the point C from the line of action of 30 kilonewton force. 30 kilonewton force is directly known. It is 1.25 meter. Directly you can write it as 30 into 1.25. 30 into 1.25. So when the perpendicular distance is not known, then only you can use components. Here if you try to use components, you will get complex calculations. Okay, that is why, as perpendicular distance of the point C from the line of action, okay, is directly known, directly it is 30 into 1.25. And about C, if you apply 30 kilonewton force in this direction, no, it is tending to cause anti-clockwise moment about point C. Sign is minus. Okay, therefore the answer is, let me calculate the answer. Yes, minus 417.5, minus 417.5 kilonewton meter is the answer. Okay, so why I told you to calculate moment about C instead of calculating moment about O, no? So you will have direct calculation 13 to 1.25. If you try to calculate moment about O, no, you have to use components and you need to find perpendicular distance. It is very difficult. That is why I told you to calculate moment about C. Okay. Now we can find x-intercept. X-intercept is equal to sigma m by sigma fy, which is equal to minus 417.5 divided by sigma fy is how much? Minus 135. The answer is 3.09. Okay, then y-intercept, which means that the resultant is intersecting at a distance of how much? 3.09 meter. Okay, 3.09 meter from the point C. Okay, resultant is intersecting the base of the dam at a distance of 3.09 meter from the point C. That is the meaning. Okay, that is how we located the position of the resultant force, sigma m by sigma fx 417.5 divided by Fx is 24 if you want. Yes, 417.5 divided by 24, 17.39, 17.39 meter. And D also you can calculate sigma m by resultant force, or sigma m is minus 417.5, resultant force is 137.11, therefore 417.5 divided by 137.11, 3.04 meter. You have to put the answer with positive sign only because mod is there. Okay, so to this uh, the position of the resultant force we have determined. Okay, so this completes the problem. Thank you.